In the previous lecture, we discussed the center of gravity for a system of a particle and also for the rigid body. In system of particle, we use the summation, and in case of rigid body, we use the integration. Also, we discussed the center of mass for the system of particles and also for rigid bodies. And finally, we discussed the centroid of a body. And we said that the centroid is independent of the weight. It depends only on the geometry of the body. And we have three types of the centroid. We have the volume centroid, and we have the area centroid, and we have the line centroid. The most important one is the area centroid, because mainly you are going to deal with 2D, which means that we are going to deal with areas. So it's very important to understand the area centroid. Here, like you can see here, we have the centroid, the area centroid for the common shapes. Here we have the triangle, we have the rectangle, and we have the semicircle, and we have the quarter circle. That is going to help us in this lecture today. Today, we are going to talk about the composite body. So what does it mean by the composite bodies? The composite body consists of a simpler bodies connected together like a triangle and rectangle. So in engineering, we are going to use the composite bodies a lot. So when we are going to have composite body, that means it's consisted of simpler shapes like triangles and rectangles. For example, here we have a cross section for a beam, and the cross section here is the composite cross section. It's mean that I'm going to divide that composite body into simpler common shapes. For example, this one here could be divided into rectangle, triangle here, and rectangle there. So when I'm dealing with composite bodies, that means I can divide the composite body into simpler common shapes. So composite body can be divided into its composite parts. So like that here, we have 1, 2, 3, and 4 parts. And like you can see here, we have composite body. So we need to integrate. We need to integrate in order to know the centroid, area centroid. But luckily, since the composite body, it could be divided into a number of triangles and rectangles, I can determine that without using the integration. But I need to know the weight and the center of gravity of each part. So I need to know the center of gravity for that part, and that part, and that part, and that part. In this case, I'll be able to determine the centroid or the center of gravity for the composite body without using the integration. So each part is going to be treated separately, and then we are going to use the summation. For example, if I know the weight and the center of gravity for each part, then I'm going to say that the centroid in x-axis, or the center of gravity in x-axis, is going to be the summation of the x hat times w over the summation of the weights. Similarly, I can do that in y, and it could be done for x. The summation here is a summation for the separate parts. And also, it's very important to know that if the body has constant density or a specific gravity, so if this body here, they have the same specific gravity, in that case, the center of gravity is going to coincide with the centroid of the body. So the location of the center of gravity is going to be the same as the location of the centroid. But the body should have constant density or constant specific weight. So now in order to, we say that the centroid is very important. And in order to draw the centroid, for example, if you want to get the volume centroid, you are going to replace W here with V. If you want to determine the area centroid, you are going to replace the W with A. If you want to get the centroid for a line, you're going to replace the W with L. So also for the composite bodies, I'm going to determine the centroid using the line centroid using this formula, or the area centroid using those formulas, or the volume centroid using those formulas. So now I'm going to show you the steps in order to determine the centroid for a composite body. First step needs to be done. We need to divide the composite body into simpler shapes. The first step needs to be done. Then if you are going to have a hole, you have a gap inside your composite body, or you are going to have a geometric region having no weight, then consider the body without the hole, and the hole has an additional composite part having negative weight or size. So if I'm going to have a gap inside the composite body, then that gap here, the area is going to be negative if I'm going to consider the whole part without the hole. So if I'm going to have a hole, then I'm going to ignore the hole, but then the hole is going to be with negative area or negative weight. Then I need to know the x hat, y hat, z hat for each particle, and then using the previous equations, I'll be able to determine x, y, z of the whole body. To understand this more, we need to solve example 1, so that we are going to connect all these ideas together in one example. So here we have composite shape, like you can see here. The reference is located here. So the reference for me is here, x and y. The reference also could be there. So we put the reference here. So it's mean that I'm going to locate the x and y depends on that reference. So here the value of x is 0 and the value of y is 0 as well. So the question is, we need to locate the centroid of the plate area. So here we are dealing with area. That means it's required to determine the area centroid. I'm going to have a dimension in x and dimension in y. So let's see how we are going to handle this problem. We say that the first step is to divide the composite body into simpler shape. So here we have composite body. We need to divide it into simpler shapes. We have more than one solution for that. You may say that I'm going to have triangle here and rectangle there and a square here. Or you can say that I'm going to have triangle here and rectangle there. In that case, this one is going to be like a hole. So this one, I'm going to include it as negative area. So I have here more than one option. I could say that I have this part and that part and that part, or I could say that I have that part here, triangle, I'm going to call it the part 1, and here I'm going to have rectangle, I'm going to call it part 2. But here we have a gap, we have a space here. So I need to subtract that part. So I'm going to create new part, I'm going to call it part 3. But that part here, the area is going to be negative because I need to subtract that area from here. Similarly, if I'm going to have a hole there, I'm going to ignore the hole, but I'm going to create new part here, and the area is going to be negative. So this example is very important to let you know about how to deal with a hole or a gap inside your composite body. Then, again here we're talking about if the body has a hole or geometric region having no weight. Then we are going to consider the body without the hole, like here. Here we consider the body without the hole, so we ignore the hole. Then the hole, we put the hole as additional composite body here, and it's going to have negative weight or size. Here, since we are going to get the area centroid, the area here is going to be negative. Then we need to determine the centroid of each segment is located. So here we have part 1, 2, 3. We need to know the X and Y, the centroid for that part and that part and that part. Like I said in the beginning of this lecture, we know the centroid of triangle and also the centroid of rectangle. Here we have only triangles and rectangles. So for triangle here, if this one is a reference, which means that here we have 0, 0, then the distance in X is going to be 1/3 of the base. The base is how much? Is 3. 1/3 of 3 is 1. So in X I have 1, and also in Y it's going to be 1/3 of the height. The height is 3, and 1/3 of the height is 1. So for this triangle, I have 1 in X and I have 1 in Y. Then regarding the rectangle, we know that the centroid is going to be located exactly at the middle. So here I'm going to move half of the base. The base is 3 feet. The third half of the 3 is 1.5. Remember, that distance is going to be negative because the positive is here. Everything is going to be located according to your reference. Since my reference is here, that means that distance here is negative 1.5. Regarding the Y is going to be positive, and also again 0.5 of the height, half of the height. The height is 3 feet. That means half of the height is 1.5. This one is going to be positive. Finally, we have the whole part, which is here. Again, the center, the centroid for that segment exactly at the middle. So remember here, I need to move from the reference. I need to know the value of X according to the reference, not that point. If it's that point here, if the reference was here, X and Y, then since this one is 1, so I'm going to move minus 0.5. And since this one is 2, I'm going to move only 1. But I'm going to move here from the reference. So from here to here is 2. And from here to here is 0.5. It means the distance from the reference is 2.5 minus 2.5. And the distance in Y is going to be 1 plus 1. So here I'm going to have 1 plus 1, which is 2. So here I am going to have minus 2.5 and 2. Once I finish from that step, then everything is going to be easy for us. We are going to use a table, and that table is going to facilitate the process of determining the centroid. So now we are going to use that table shown here. We have part 1, part 2, and part 3. So here part 1, 2, and 3. In order to use the formulas to determine the area centroid, I need to know the summation of the areas. I need to know the summation of X hat A and X and Y hat A. Remember those? I need to determine the summation for this one and that one and for the area. In order to do that, I need to fill in that table here. So here, I need to know the area for all the parts, for part 1, 2, and 3. For part 1 here, the area is half times the base times the height. So I'm going to have half times 3 times 3, which is the height. Then the area for part 2, the rectangle, is the width times the height, which is 3 times 3. And for this part, I'm going to have 1 times 2. So here, 1 times 2. But remember, this part is the whole. That means it should be negative. So the area here should be negative. Whenever you have a whole, you need to put it as a negative value. Then I need to know the centroid for part 1. We already determined the centroid for part 1. In X, we have 1. In Y, we have 1. So I'm going to have 1 and 1. Then how about that value? X hat A. So here I have X hat, and here I have the area. So this one times that one is going to be 4.5. Similarly here in Y hat A. So now I finished from the segment 1. Regarding segment 2 or part 2, I need to know the X and Y. For part 2, X is minus 1.5 and the Y is 1.5. Again, I need to multiply this one by that one and this one by that one. Then the final part, which is part 3, I have the distance in X is minus 2.5, and the distance in Y here we have 2. Then multiply this one by that one and this one by that one, here and there. Now easily I can know the summation of these areas. You need to, if I have negative, you need to sum by the negative, algebraic summation. So here you need to apply algebraic summation. So the summation for those areas came out to be positive 11.5. Also, I need to know the summation of X hat A. Came out to be minus 4, because this one here minus is the value here is large. So it makes sense that the value here came out to be minus 4. Here the summation came out to be 14. So now in order to determine the centroid in X, so now we have the composite body, we need to know the centroid in X and in Y. Also, we need to use your common sense. If this one is the composite body, is it possible that the centroid to be located here? No, I don't think so. So you see here, the part, that part is bigger than that part. So I expect the centroid to be located somewhere here. So also we need to use your common sense to know whether the centroid is correct or incorrect. Using common sense is in engineering is very important. So according to the formula, the centroid in X for the composite body here. So we have X bar represent the centroid for the composite body in X direction. So we have the summation of X hat A, which is here, minus 4, and here we have the summation of the area. So I'm going to have minus 4 over 11.5, and the answer came out to be minus 0.345 foot. So here I'm going to move into this direction since it's negative. Now I need to determine the value of Y bar. Y bar represent the centroid in Y-axis for the composite body in the problem here. Now I know the summation of the Y hat A, which is 14, and here is the summation of the areas. And the answer came out to be 1.22 foot. So in X, I'm going to move negative, and in Y, I'm going to move positive. So the equation is here. Does it make sense? Yes, it makes sense for me. Okay, so after you get the answer, you need to understand how to use your common sense in order to know whether your answer is correct or incorrect. Now I'm going to give you the chance in order to ask questions about this example. So now let's move to example 3. In example 3, also they want to know the centroid for that area here. So we have an area and we need to determine the area centroid. And in this example, he asked only about the distance in y. He want to know the area centroid in the y axis. Here, since we have symmetry, so we have symmetry about y, which means that this part is a mirror for that part. And if that's the case, if I'm going to have a body like this one, and I'm going to have symmetry about one axis, that means the distance in y is going to be 0. Since I have symmetry here, the distance in x here is going to be 0. So the centroid is going to be located at the y-axis. So x is going to be 0. Then the value of y is going to be located here. And also, again, you can make a guess. If I'm going to have a body like that, of course, in x is going to be in the middle, no distance in x, and in y it could be somewhere here. According to the areas, it could be somewhere here. So I'm going to expect the value of y is going to be here, which means that at 2.5 more or less. So you need also to make a guess so that you can know whether your work is correct or not. Like I said, since I have symmetry here, that means the x bar, the centroid in x-axis is going to be 0. I'm going to use the reference to be exactly at the center. You may use the center here, and in this case, the value of x is going to be 3 inches. If your reference was here, then the value of x is going to be 3 inches. But since you install the reference exactly at the middle, that means the value of x bar is going to be 0. Now, since the value of x is going to be 0, I'm not going to pay attention for the centroid for that part in x-axis. So the number of column is going to be reduced by 2. So now let's discuss the first step need to be done. The first step, we need to divide the composite body into simpler shapes. So I have composite body. I need to divide them into simpler shape. Like I said, we have more than one solution for that. In this case, I'm going to divide them into 4 parts. Part 1 is part 1, part 2, and part 3, and part 4. So I divided the composite body into 4 separate parts. Then they say that if the body has a hole, here we don't have any hole, so this condition we are going to ignore it. Then we need to know the centroid of each segment. So we need to know the centroid for that segment, and that segment, and that segment, and that segment. And like I said here, since x is 0, I need to know only the value of y for each segment. So instead of having 5 columns, so we used to have 1, 2, 3, 4, and 5. Since the value of x is 0, I'm going to ignore the x. So I'm going to concentrate with y hat and ay hat, because x hat or x bar is 0. I have part 1, 2, 3, and 4. Regarding part 1, I need to know the area. The area for part 1 is 1 inch times 7.5. So we're going to end up with 7.5. Regarding part 2, here we have triangle. the base is 2.5, and the height is 1.5. So I'm going to have half times 2.5 times 1.5, came out to be 1.875. And this area is similar to that area. So this one is the same as that one. Regarding number 4, here I have 6 inches, and here I have 1 inch. So the area is 6 inch squared. Then I need to know the centroid in y-axis for the part 1. Remember, the y here is going to be from the origin. So I need to know the distance in y from the centroid of that particle to that reference here. For that particle, since the height is 7.5, that means the centroid is going to be located at 7.5 over 2. So from here to here. Then I'm going to add 1. So y hat for part A is going to be 1 here plus 7.5 over 2. 7.5 over 2 is 3.75 plus 1 is 4.75. So I'm going to end up with 4.75. Then I'm going to multiply this one by that one here. Then let's move to 2. So I need to know the y distance, the centroid of that triangle with reference to that point. So here I have 1, and from here to here, the height is 1.5. We know that the centroid is going to be located about 1/3 of the height. 1/3 is 0.5, and then I need to add 1 because the reference is here. So I'm going to have 1 plus 0.5, which is 1.5. Similarly, for that triangle here is 1.5. Now regarding the rectangle here, the y is going to be half of 1, which is 0.5. So here I'm going to have y hat, which is 0.5. Then multiply this one by this one, and by that one. So I'm going to have this number, and that number. Now I'm going to determine the summation of the areas here. And also I'm going to determine the summation of the AY hat. Now I'm in position in order to determine the value of Y bar. Y bar represent the centroid in y-axis for the composite body, for the whole body. So Y bar is going to be the summation of Y hat A, which is here, and summation of areas, which is there. So this value or that value came out to be 2.565. 2.565 is more than that distance by just a little. So in the beginning of the problem, I made a guess. And according to my guess, I believe that value is correct. Okay, so it's very important to make a guess so that you will be able to know whether your work is correct or not. Here we have a problem. If you really understand what is going on here, we have a body. It's composite, and it could be divided into 2 rectangles here and there. And the reference this time was put, it has been put here. We need to know the centroid of the composite area, X bar and Y bar. And we have choice A, B, C, and D. Try to solve this one and try to guess the answer. Okay, I'm going to stop here. If you have any questions regarding this problem,